Hi, Ryan. Can I admit him?
Okay, what?
Do you want me to click admit?
Yeah, click admit. If it's Ryan. If it's not, don't admit.
It's Jordan.
Okay. Somebody else. Oh, he just tried. All right. Okay.
Can he see me? No, he can't.
No, he's seeing this over here. Webcam. Okay. All right. Hey. Okay. Real quick here. We have a couple different things we have to get through. Number one, we have to get the precise definition of a limit. This is required. I just screenshotted it. We're just going to go with the precise definition. Now, we'll discuss it. I'll throw up a graph up here in a minute so we can actually discuss like what is this monstrosity saying. Then we are going to go to those examples we did yesterday. You guys had a phenomenal time of trying to figure it out and asking the right questions. Today, I'm going to throw a kink in the plans now.
Enjoy this.
So this, I want to keep it straight what you guys did yesterday because you guys had it nailed down. But we're going to add little new things today.
Isn't Ryan
So,
regards today?
yes.
Will you, when you dumb it down, you actually write it on the board?
Yeah, so, yes, that's the graph I'm going to show you. To show you what this is saying as an easier thing to look at.
Lord, I understood so well yesterday. Look at my notes. Just nothing.
No, that makes me worried. So,
Why?
because when it finally confuses you, where's your notes at?
It's okay, because I understand the first part.
Okay, well, that's good. Happy to,
I'm
happy
more
to-
genius right now.
Okay, all right.
Took my Flintstones.
You're on a different level. All right, so.
I'm a little different.
Okay.
I'm grown.
All right. So let's talk about what this is saying. So this is the definition I want you to have. I'll have this on the website, so if you need this. But it says, let a function be defined upon a certain epsilon interval where a number a and except for any possible a itself, where the limit of f of x as x approaches a certain number is L. That's the limit. It's super confusing. There's a bunch of jargon there. Basically what it is saying is what I tried to walk you through yesterday. This is the notation we were using yesterday. This is the word limit. They just abbreviate it. This is the variable that you're using. This is the number you're going to try to evaluate it at. So let's say that as x approaches 3. We're going to go find 3 in the x-axis or whatever variable axis we're dealing with. But this is the number we're trying to evaluate at. And this is the formula you're plugging it into. So this is the formula. So maybe they give you some crazy formula and you're going to go plug it in and see what that answer is. The answer you get is called the limit. That's my dumbed down version of it.
Huh. I got it for free.
What?
It gives you one book for free.
Done.
What happened?
Were you sure it was me?
Yeah, $5.
5 to 6. Wait, what is it?
No.
They're not getting it.
I love Audible.
Is it on? What book was it on?
When you're
Or
driving,
what?
just listen to books.
Not what the
All right.
website.
Okay.
Oh, I don't know.
Audible?
You drive and listen to books?
Yeah. I went through in the past 2 years, I went through 160 books.
Crikey.
I hate books.
Big books too, 1,000-page books, within a day or two.
So how far do you drive?
Yeah, what the hell?
Well, the problem is so I'll drive and then when I get home, I'll just have it on my phone still playing. So I'm grading papers, just pounding through books for hours.
How do you listen to
What?
Do you even listen to them?
Yeah.
So is that what you wanted?
I don't need to do that.
Oh, my
My brain
multitasking
is already
ability
in
is
it, so I just
unreal.
pounds for
And I can
not good
almost
for you.
memorize the books. It's terrifying.
What?
Yeah. So,
So what books have you read?
read? Lots.
Or
I can
listened
I
to?
can, All right.
Wow,
Please.
Is that when you circled what you
Just
wanted to
count.
do?
Yes, that is one of the main things. Okay, shh. This is the main thing I want you to have. Now, I'm required to show you the full definition. This is the main thing. Now, this is the thing I want you to have. It's the formula. Now, there's a part at the bottom here. This extra piece. This is the college level kind of thing that if you're going to Calc 1 in college or a college level geometry course or whatever you're going into, this second definition, this part right here, is crucial that you understand what it's telling you. Now I'm going to read it out loud and then we're going to go to the graph here in a minute and discuss it. So, okay, so here's what it says.
Wait, what's
Okay.
the L stand
So
for?
do I have to pay for that?
Limit.
No, like $1.
The actual answer for the limit. The solution for your limit.
If it means
Okay.
I get it, then yeah.
Now, Okay, let's talk through this. So here's what it says, then I'll go and I'll show you in a graph what it means, because this might confuse you. Okay, it says for every number epsilon, so they picked a new letter, it's a Greek letter, so for every number epsilon that is greater than 0. Okay?
Right.
Yeah, alpha's used for something different. So every epsilon that's greater than 0, so some number, there is a number delta that is also greater than 0 that can get you in that window. Okay? And so they say, you know, there's numbers between 0 and delta that when you subtract them from x, you can be in the boundary. And it will give you an answer that is less than epsilon. Now, it's super confusing until you actually see what that means on a graph, and then it makes way more sense, and it goes off the stuff we did yesterday. When you start looking at graphs, and you go from the right and left side, and you pinpoint down to where the limit sits.
So we don't need to write that.
So, this is just the book definition, what they say. But I'm going to show you on a graph what I mean by that.
Do you have fingernail clippers?
So I do.
Can I use it?
Yes.
I think. Never in 100 years what I thought.
Whoa, weapons being thrown.
All right. Now, let's walk. I don't know if you're still writing that definition down. I'll leave it up there.
It's gonna dumb down the definition.
Yes. This, okay, for the top part, hey, the top part, this is the dumbed down version. This is the part that what it stands for. This is what we talked about yesterday in class. Okay? The bottom part I haven't dumbed down yet. I haven't done the second part of the definition. That's the part we're going to do next.
Why would I need a dumbed down version? I understand it
Okay.
already.
Yeah, right.
I'm lying.
I was gonna say, dude.
Wait, what does the fish hook thing you mean?
Okay, this is the main thing you need, the thing I circled. This formula is what we were using yesterday.
Fish hook me.
Yeah, I got
Okay, this part I haven't dumbed down yet. We're going to get to that next.
What's
Talking about epsilons and deltas.
You're talking about the one that kind of looks like you.
So there's the elephant one, and then there's the.
That's this is epsilon,
That looks like a
and this is
backwards-
delta.
Is that E
What
and
do you
D?
think?
Why isn't it a triangle?
What?
Why isn't it a triangle?
What?
Find out.
That type of delta is a change in. This delta means a variable.
All I know is. Oh.
Yeah. There's a slight difference.
Is that D in the alphabet?
What hole?
D
Greek letter.
I heard what hole.
Epsilon.
and D.
Epsilon.
And yeah, delta.
Mine's probably like, what is
Okay,
it?
all right. We ready to go here?
Yeah.
Next slide.
Okay, oh, we still got people waiting.
How do you spell epsilon?
Wait, what's
EP slide.
There's a number.
EPSILON.
Is it an S?
Right here?
Remember, you can't have.
No, the other one.
Is that an S?
That is a delta. It's a D with a little tail on the top. It's just a very cursive D with a little tail on the top. To me, it looks like a
Looks like
flamingo.
an
That's a D. I thought it was an S.
No. It's a D with a little tail.
Or a 6. It's having a little issue, like scoliosis on the back.
Okay, all right.
It was like,
Stop.
What the heck?
Stop. Inappropriate. All right. Now, let's go through the graphs now. So, we're still good? Are you still ready? Okay.
You tell it to me.
How about
what
this?
one should I write? Should I write the very bottom or should I write the?
You want to put the part in the circle, for sure. You need to have that formula written down.
Okay.
The next part, I might just put the graph over here. I don't know if I need to necessarily have a formal graph of it, unless you want a really nice clean graph.
No, right there.
Okay, all right.
Start drawing.
So this is going to be the dumbed down version of that bottom part. Okay, so imagine you have a graph, and there is a curve going off of it. So
Curve.
Erica, you can just draw on your little graph that I provided you.
Sure, sure, sure.
Okay, so no matter what this thing is, so I'm just gonna say that this is my curve, right? It's got some stuff going on. I don't even care if there's holes and gaps in it. Okay, so what they're saying is that I can pick some x value, right? There exists some x that I'm trying to approach. And what I'm gonna do is pick a delta, and delta is this number that goes from like just around it. There's this gap that I can either add delta, right? Add delta, or I can subtract delta, right? I can subtract delta, so I'll make a little band around my x, if that makes any sense. Like I can go to the right of x and the left of x by just a really tiny number, and they call it delta. It's a very, very small digit. So that's what they're saying. You're picking some delta that is greater than 0, some little tiny number, give me any decimal you want, and I'm picking it in such a way that it is the distance between your number. The distance between your number is going to be from 0 up to delta. So delta is this little like spacing. I'm adding delta, subtracting delta from x.
From 0.
from that number, whatever x is. X could be the number 0, it could be the number 20, I don't care. X is the number I'm trying to approach, okay? And I'm picking this delta, this band that goes to the right of it and to the left of it, and delta is the spacing that I'm using, okay? So now, when I make my spacing, and I went up by delta, and I went down by delta, it will eventually hit the graph at different locations. Do you see that?
Yup.
Now, the actual answer for x, the limit, is actually right here. The limit is where the graph is approaching. But my delta band gave me this little area above it.
So your delta band is a range.
Yeah, it's a range. You're absolutely right. That's the greatest word you could have used. It is a range around it, okay?
Jeez.
So, it is giving me this range for values like straight across. So I'm in this range of numbers that I'm around the answer. The actual limit answer was right here. It's the y number, right? That's my limit. That's what I'm looking for. But it put me in a spacing that I'm super close to it. That spacing is epsilon. It's the epsilon is the distance from the actual limit. So delta is the spacing from the x I'm choosing. Epsilon is the spacing from the limit number. It's this spacing or this spacing. If that makes any sense.
Wait, what was the first one you said?
Delta?
Yeah, the delta number or whatever is on the x and the epsilon is on the y.
Yes.
Okay, what if your line is like, so your first delta number and then it dips down and then it goes back up high.
Okay,
So then it's not actually all like one.
So, okay, I need you to draw this. Just come over here and draw this. I need to see exactly what you're saying.
I don't know if this is.
That's fine. Do the best you can.
So what is
Erica, when you're drawing, if you're going to a new graph, just take a screenshot and then we can add a new graph in there if we need.
What if it did that? And your first delta number is here, and your other one is
How do I add a graph?
over here. So then it's like way up here and up here, but your numbers are still lower than that.
Okay, all right, so, okay, he nailed this one major piece of it, okay? And he's talking about, okay, we have my x value is right here, that's the limit answer. My delta went up this direction, my delta went this way, and when you look at the band wasn't even close to what the actual answer was. They solved this solution. So in this idea, in this definition of a limit, they would like it as I go from left to right. Left to
The
right.
limit
You
does
need
not
to
exist.
say it again.
Are you sure?
Wait, what did you say?
She said if you back it up.
Okay, all right. Well, okay,
The limit
now-
does not exist.
Okay, so now to prevent what you were talking about, where this is a major issue, right? That it dipped down below where we're supposed to be. So what they say is you need to pick a delta in such a way that you pick them closer and closer together. Because your deltas that you chose were too far, right? Because it's making too drastic of a change. And my answer wasn't close to the limit answer. So what you do is you pick the delta closer.
So you're right there.
And then you pick the delta
So
closer.
is it just going to give us deltas?
It will give you the number. If you get close enough to delta, because delta has to be a number between 0 up to delta n, they prefer that it's really tiny, a very small decimal. So that way you're getting super close to what my limit is, and then that will give me a band, a range, that's close enough to L that I can just name what L is.
So delta is like a forgiveness range.
Exactly. It's a forgiveness
take.
band that you're trying to give a little bit of give and take so I can get really close to the actual answer. Okay? It's like the speed limit on a car. You just have to be within a certain boundary. It doesn't matter if you're speeding or you're going too slow. You just have to be close. So our officers around here are very lenient. It's about 5 miles. There's some places around, they don't want you to go even a mile over. So just be careful of that. So now that we have the basic definition down, the real like crude way of explaining it, we need to go to some examples of graphs like we did yesterday and kind of review what the limit is, what the functional value is, because there are two different things. I want to review that stuff that you guys were really good at yesterday, just to solidify it. Then I want to throw the kink in the plane.
I already forgot what it was.
Okay, what?
I forgot what it was.
Okay, so, yep, go to the next slide. All right, I need to find that graph. So up
There's a lot of
here,
cake already in this, so.
Oh, it's right there. Oh, nope. What are you?
there it is.
I don't know if I can handle it.
That's
Hold on.
I don't know. Why down
There.
the track.
That one? Okay. I just want to make sure, because I just threw these up here. I want to make sure you're lined up with it.
Too much.
All right.
I'm just gonna be finished.
All right, so I have a bunch of curves here. I have like a series of 5 or 6 pictures we're going to look at. Some of them work, some of them didn't. I just kind of threw them all together. All right, let me get rid of that mouse. I don't like that
Okay.
mouse up there. All right. Okay,
Who?
let's talk about limit values.
Oh.
So, if I was going to go to the limit of, the limit for this function, let's call this graph represents my function, that's f. That's my f graph, it's kind of going all over the place. And I want my x to approach the number 4. The 4 on the x-axis. I want to know, what is the answer there? Okay, so you're absolutely right.
Wait, what?
So, as we're approaching 4 on the x-axis, so I'm picking a delta band that's very close to 4. You are going to look at the graph and see where the graph approaches. So what was my answer for the y number? 2. Even though there was a hole there, the limit is getting closer and closer to 2. As I get closer, even though there's a hole, the graph is pointing me that the answer is potentially 2, even though it didn't count. Does that make sense what a limit is? Now, it could be a nice solid number, it doesn't matter. But the difference is when you actually look at functional values. That's where it's different. This is a limit. You're looking at where the graph is pointing you towards. It is different than doing something like this. This is different. This is actually asking you to go look at the graph and see where the solid dot at 4 is. I don't have one, so there's no solution on that problem. So the problem for my function doesn't even have a solution. Right? There is no answer there for at 4. There was a hole there. If there was a dot above it, maybe there's a dot up here.
It would be 6 then.
It'd be 6, right? That would be the functional value. It would be at 6. The limit could be a different number than what the actual function is. It's just you have to look at where the graph is pointing. That's what a limit is. Look at the graph, see where the graph is pointing towards. Question.
So the functional number can be any of those numbers that are within the delta.
No, the
what do you call from negative delta to positive delta? What is that?
That is your delta band. That's what they literally call it.
Delta band.
Delta band.
Okay, so how does that relate to that?
Okay, so going from the actual definition to here, right? They're saying that you need to pick a delta that is close enough to the x you're trying to approach. So I'm picking a delta that in fact is so close to my number that I'm trying to evaluate that when I go up here and I look at where these deltas are hitting and I pick them closer and closer together, they're going to start to approximate where the limit's going. So as I pick the deltas closer and closer together, it's narrowing down where my
So you
function's
just like right in the middle and you're
right in the middle.
and that's
Yeah,
where-
exactly.
So
That's what you just did there is some major Calc 1, like when we get to the next section. Like that idea, just pick the middle. That's a huge thing that we're gonna do in the next section.
okay, I can do that.
Yeah, okay, good. Question.
If you like keep pushing the deltas closer and closer to your actual point,
Yes.
you can never actually reach that point.
No, but we're using the idea that we're approximating where it's going towards.
Yeah.
That's what a limit is. That's the same idea that they use with like when they look at when numbers approach infinity, right? When they approach like a positive number, we can approach what it's going towards. Like that's how they did it with pi, right? We don't know what pi actually is. We're approximating closer and closer and closer together by picking numbers that are insanely close to it and getting closer and finding the midpoint between them. And that's how they find the next digit every single time, every single year. Question?
So would delta be used if you don't like have a graph and you can't see visually?
Yes, exactly right. So if I start doing limits like this, but I don't give you the graph, now you're starting to see what I'm going towards.
So I kind of
Okay, so like say that it doesn't have like labels or anything like that.
You have to use the formulas. You have to pick numbers that are so close that they'll give you functional values. You're already doing the next section like he was. You're starting to see it. Isaac pointed out. So that stuff is what we're going to be looking at. When you're not given the graph, you literally have to pick numbers and plug them into the value because it won't work. Okay? That's really good, like reasoning. Okay, now,
astronauts make a lot of
Our
money.
table right now is so lucky.
yes,
Like a lot.
150 a year.
That's pretty good.
Holy
$150?
balls.
Yeah, but there's a
$150,000.
lot of travel.
You have life insurance for life.
Oh, really?
Yeah, there's some serious perks.
Insurance is expensive.
Life insurance for like.
I looked it all up when I applied.
Life insurance for life.
But you applied?
I applied to be an astronaut back in 2006.
How do they not pick you? I don't understand.
Don't know. All right, moving on.
Did they, did they give you like an email or anything that was like,
The only email, I didn't even get a rejection because I was gonna frame it and like put it on my wall
That you
saying
got
like I
rejected to be an
rejected. No,
astronaut?
the email I got wasn't even from NASA. It was just a generic email saying that the account that I used to apply for the position was closing in 30 days.
oh, so they didn't ever like respond?
No, because 18,000 people applied.
How many got to be?
6.
How to pick you?
So, what?
You should apply again just to see if you get.
I'm already past the age limit. The age limit for astronauts have to be less than 35 unless you're in the program already. I'm already.
Wait.
So, all
Your
right.
driver correct coming
What's
up
the
on-
age?
It's the age that they want new astronauts are from 25 to 35.
Travis,
Do
they have to be like-
you
I have to be
25.
As soon as I hit
Start
25, I'm
applying.
applying. They'll be like, this kid didn't graduate college.
Okay, did you graduate
high school.
Shh. Okay, all right, now let's talk about the kink in the plans. You guys are really good at figuring out limits.
Me,
But now,
Matt, Joe, Joseph.
limit as x approaches 2 for f of x. Morgan, what did you say earlier?
It doesn't exist.
Doesn't exist. Does not exist. D N E.
I got 10 out of
Shh. Okay. Hey, stop talking. So, okay, the limit doesn't exist. Let's talk about why. As I did my little delta band,
Motion alert
And-
detected at the pool table.
yeah, sorry. All right, so as I approach from the left side of 2, and I approach the right side of 2, do you see how the graph is approaching different values? They're not pointing towards the same number anymore. That's why the limit doesn't exist. Limits don't exist when your graph is pointing at 2 separate numbers that are not even remotely close. It's not like I can get infinitely close and almost approximate it. They're on 2 different levels. One's like they're totally off from each other. There's too big of a gap. It's not like it's
So
connected
your
like
range
this.
you can't just go boom 2.
It's the same with -4.
Yeah, same with -4. That these gaps are too big. It's not like they're approaching from the right and left side of the same dot, an infinitely small circle. Their gap is too large. It's
So
more
you
than
can't
just
just go down 3 from 5, up 3, and then go boom 2 is my answer.
no. So that's the problem. So the idea is that they have to be approaching the same digit for you to have a limit. Okay, question.
So when you do have like 2 lines that are really close to each other, could you use your deltas to approximate a number?
No, limits don't exist automatically if there's a separation.
Wait.
So
Does the open circle just mean 2 arrows going?
it means the arrows are pointing like that direction.
I don't know how I just picked that up,
All right.
but I just picked that up.
All right. Anyway.
Wait,
now,
so that where it stops at the open circle, does that just mean like a really small arrow?
yeah, it's just pink. Okay, now. Okay, so let's talk about the kink in the plans. Because we talked about the do not exist yesterday. We got to throw a kink in the plan.
Why?
There is a way to evaluate a limit, like what you guys were saying, if you only approach it from one side. Like if I didn't see, let's say that this part of the graph was covered up, and I didn't know it, and I was looking at just the leftmost numbers up to 2. So how they write this, they write it like this, and this is something you need to have in your notes. The limit as x approaches 2 from the left side. Notice I put a negative sign after 2. This is approaches, so I'm going to write this down. This is my words I'm saying in my head. This approaches 2 from the left.
Negative means left.
Yeah, from the left. That's what that little negative sign means, after. And it goes after the number, not in front of it. After the number. I'm approaching 2 from the left for my function, f of x. That limit could exist. The overall one didn't when I approached 2 from both sides. But if I just approached from the left and I didn't even know there was a right side, and I'm just approaching, what is my graph going towards?
-1.
-1. That's the answer. My graph is going towards -1 when I hit 2. You can see that. I didn't see what the right side's doing. I don't care. I'm just looking at from the left side going up to 2 on the x-axis. Where is the graph going to hit?
And that's called the limit.
Left or from
That is the limit as x approaches 2 from the left side.
Okay,
starting at 2.
but I
right?
thought
Going towards 2.
fundamental thing of graphs is the arrow means it keeps going.
So why is it?
Right now, that dot was an endpoint. So
So
we
why is it
stopped.
-1? Should just be 1.
We're below the graph. So we're approaching 2 from the left. You have to read off what the actual functional value was.
Oh.
So like, wherever there's an open circle, it just means two lines are coming in like a point and radius.
Yeah. Yeah. So, all right, now.
And you
that's-
can't be sure it's 2, right? When they're pointing, you can't be sure it's 2, so you gotta do the range.
Yeah. Okay. Now, if I was going the limit as x approaches 2 from the right side of f of x.
Yeah.
Approaches 2 from the right side. Is it approaching one single digit? 5. Even though it's an open circle there, it is approaching 5. It's looking like it's going to hit 5 as I go closer and closer to it. So limits, even though they don't exist when you look at it from both the right and left at the same time, if you look at it from one direction only, like you're blind to the other side of it, you could see where it's going towards.
Okay, but I thought the whole point of that open circle was that there's 2.
On that particular case, the arrow is on the right side only, and it's pointing like it's going that way, but it never actually hit there. It's pointing where it was
So
supposed to
what's the
go.
difference between a closed circle and an open circle?
Closed circle, it actually hit that dot. It hit that number and it included it and it stopped there. An open circle means you got infinitely close to it. The arrow is pointing at it, but you never actually reach it.
So how could you say that the limit is 5 then?
The 5, because that's where the number's pointing towards. As I pick numbers closer and closer to 2 from the right side, let's say I pick like 2.0000001, right? A number super close to 2 on the right side of it. And I plugged it into my formula. It would spit out a number like 5.0000001.
Yeah.
And if I plugged in another number, it would point me closer and closer to 5. So from the right side, it looks like it's going to hit 5. I just don't know it. Let's say I was blind to it.
So it's an assumption.
I'm getting closer to 5. So imagine there's like a cover here and you're like, okay, where is the graph pointing towards? Well, it looks like it's getting closer to 5. That's what I'm saying. I don't care if it's an open or closed circle. It's looking like it's going there. I don't care if it actually reaches. Okay.
But it's looking like these 2 arrows are pointing towards a number, but you do care because you don't say the absolute limit.
Yeah. Okay.
Okay, that's kind of stupid.
Question.
but
So a closed circle
Doesn't mean anything.
includes that number
Yes.
that it's on.
Yes.
But an open circle includes numbers around it,
Round it.
but it doesn't actually include that
Yes.
number it's on.
Yes. It would be like a hole in the graph.
Oh. Hence why it's an open circle.
Yes. If you ever want to know, like, how do you get an open circle on a graph? This is how you get an open circle. Imagine that I had a problem like this. And I was going to divide by x plus 1. Let's say you type this in Wolfram Alpha or Desmos, and you type this in. This graph would look continuous. It would look like a line. How I know that? It would look like this. If you actually divided these, you factor the top, which is x plus 5, x plus 1, and the plus 1, and the plus 1's top and bottom would cancel. So it doesn't actually have a vertical asymptote. So if you actually graphed that into Wolfram Alpha, it would just draw this. It would draw that. It would draw a linear equation. It would start at positive 5. It would start at positive 5, and it would go up 1 over 1, up 1 over 1, up 1 over 1, right? It would draw something like this. But what you wouldn't notice is right here at the number 1 for x, or actually negative 1 for x, this spot right here, at negative 1 for x, there is the tiniest of holes, and you wouldn't notice it. It wouldn't show up if you typed this into Wolfram Alpha, but if you typed this, it would be, because you couldn't plug in negative 1 into the original problem, because it would divide by 0. So it would throw out that number, but it wouldn't show you it. You wouldn't even notice it until you actually clicked on it, and it says it doesn't exist.
So I have to zoom in really
You'd have to zoom
far.
in super far, and then like even on my graphing calculator, you'd have to zoom in like really, really close, and eventually you'll notice like it'll be a line, but there'll be a gap in the line, and there'll be a little circle there that's open, and you wouldn't even notice it. So Okay, it's one of those weird things that you start to see like the purpose of what these are called. This is called the removable discontinuity. You removed it from the graph even though it didn't cause any issues. It didn't cause a vertical asymptote, didn't cause any other issues. So when we look at the graphs in these next couple sections, so if you want to flip to the next slide here.
That one?
If we start to look at things like this, there's a vertical asymptote here. So my graph as I approach from the left side of -1, or the left side and the right side, these things are going up. They're not approaching the same number.
Don't touch it either.
They're going infinitely close, and you can start to see it. That area would not have a limit to it, right? There's an asymptote there. We wouldn't approach the same number from the right and left side unless you looked at one specifically by itself. If there's a sharp edge, there's no limit. So there's little things we have to discuss. So tomorrow we'll do more.
So I zoomed in as far as I could.
Isaac, can you imagine my
Jared, did you find any?
Just like,
Right
I drew
there.
it.
my elbow? Yes.
This kid says he can fit
And what?
The director of.
All right, see you around.
Jared, what'd you do?
You went like this.
Climb down.
Ryan,
Don't
what
see that.
Not at all.
I asked him, I wrote, and I go, do you know what you're doing? He goes, no.
That's why. Poor kid. Comes back tomorrow and he's gonna be like, what is this? What I miss?
Yeah.
Everyone be like, just quit.
Are we talking about
my life right now? You're done. You had your chance. You ain't coming out of there. Go!
You start.
Come on, the board told us to, and I want my thing all.
Oh, Jamie!
Dang it.
Oh, got it from the co-op. Nice.
Okay. I think we should be fine.
Yeah.
Okay.
Someone's probably
Chloe, you're taking this.
I think Kylie sat there yesterday. That's what the book
I got forced to read it.
Tomorrow.
Mr. Ward, can I go use the restroom?
Yes, man.
Oh, I better get my fingernails off this desk.
You just, you're nasty.
Disinfectant.
Oh yeah, by the way,
At least I got them.
Oh, I gotta. That's my dad.
Lord, I get out of here at 2.
I could have left them for you, Lorelai.
I'm glad you didn't.
They'll be grateful. Sorry.
I don't think you are though, because you thought it was funny. I hated it. You want to see how I cheated on my stats?
How is that in there? Yep.
Sigma. You know what you're doing? What did she say to you?
Emily, you're on it, and then Marlena's down.
You're the last one.
Oh, I asked her.
Oh.
She said, hopefully by tonight. I don't know.
I do like tonight. I can't watch my dragon from the
I'm really eager to
Apparently,
I
Emily.
said,
Yeah.
What'd you get?
I need the way to
What
tie
did you
it
get?
in, so Isaac and I can
Oh, yeah. For like,
I'm going to 1%, and I'm probably going to love it.
I was like, going 56.
I said,
I got 24.
Damn, I like your color.
There's like a million people.
Okay, but I think everybody got. Heavily
You don't think you would.
We all did this, right? Did you do the table? I
I didn't bring my notebook.
My notebook. I like the table method.
And I can't wait until.
Oh, it's so much work
We got a
to just
couple
like
people
write
joining.
on that. I can do it. Add it all up.
Fight her for it.
Oh, wait, you.
I'll have to go get my notebook.
Oh, I got a toner on my hair.
All right.
Can you do
Okay, we're good?
your hair just right?
Oh.
Yeah. I'll add them in.
Oh, there's.